This problem of finding the shortest substring that has all the characters that we are looking for is clearly very, very similar to the previous problem, which was to find the shortest subarray that added up to a given target. The reason is very simple, because there could be many, many substrings out there which meet the criteria that they have at least one character, but we are looking for the shortest of this. And in this case, it's clear that the shortest will have length of 3 because each character will appear at least once. We are interested in substrings, which means all the characters that fall within the bounds of 2 pointers, just like in the previous problem. And hence, this is a sliding window problem. Clearly, a variable size sliding window, like we discussed, there could be many such substrings. We got to find the minimum of all of that, and hence we can expect that the behavior of the algorithm, the flow of the code, is going to be very similar to what we have just seen, and similar performance improvements can be, let's say, expected as well, right? So here, basically, the naive method would be to look at all the substrings and find the minimum of all of that. But we don't need to do that. We can use a sliding window. Before writing any code, however, let's just kind of take a bird's eye view of this whole thing. The data structure we used for the shortest subarray problem was the list, specifically a list of positive numbers. That was vital to our development. The data structure we'll use here is a string, but again, indexing works exactly the same for both, so no issues there, right? The method used would be a variable size sliding window, and we'll do the same thing here because we do not know upfront how large the window could be. Obviously, here there's a difference because we know the shortest window has to be 3, but then we may be looking for some variations. For example, we may be looking for the longest let's say, a substring that has all the characters and so on, right? To move the right pointer, which means to expand the window, well, the logic we took is that, look, if the sum of the sub array is less than the target, then I expand. The equivalent here would be that the substring right now does not contain all the characters, which means maybe it has only 2 characters, so it has only 1 characters. I must expand to see if my new character coming in is meeting the criteria, is like completing the, let's say, the set of characters that we need, right? Also, if the sum was equal to the target, we move the right pointer. I spoke about this in detail. The equivalent here would be that, look, I do contain, all the items, and they are basically there exactly once. So indeed, that's the shortest subarray. But I will expand the right pointer anyway. I'll expand the window because perhaps the problem could be find me all such occurrences, right? Basically, we need to expand the window to see if the requirement is being met. Yeah? On the other hand, to contract the window, we will move the left pointer as before. This happens when the sum of the sub array is more than the target. So I've gone more. I need to contract the window to see if I can, find a shorter one. The equivalent here would be that, yes, I did find a substring, but that contains more than one occurrence of each character, right? So at least one character. So in this case, yeah, let's look for a shorter one. And the way we do that is moving the left pointer. So very, very, very similar. But one thing is clear, that in this problem, the criteria is based on how many times the characters are occurring, which means that we need to create a frequency map. Basically, will tell me, okay, in a given substring, how many times, let's say, a character A occurs, a character B occurs, character C occurs. Basically, every time a new letter enters from the expansion of the window, we will increase the frequency map. Every time a character, let's say, leaves the substring, we will decrease the frequency map, right? So, for example, if the right pointer is pointing to C, we'll increase frequency map for C by 1. If left pointer moves from A, so we'll reduce the frequency map corresponding to A by 1. It's kind of same as adjusting the current sum. We'll see some examples for this before we start writing the code. Do think about it. I hope you found this interesting. Do look at our website, www.yby.in, for more such content and enjoy programming. Take care. Thank you so much. Bye-bye.